we can extend the formula to curves that are revolved around the y-axis. So the formula here at the top gives us the surface area when we're revolving around the y-axis. And you can see it's very similar. I'm going to do an example of this one here. It says find the area of the surface generated by revolving the curve x equals e to the y plus e to the negative y, the whole thing over 2, from y values between 0 and the natural log of 2 about the y-axis. So using the formula, I need to find the derivative of that curve x. So I'll go ahead and write that down here. Dx dy is going to be 1/2. Then it'll be e to the y, because when we take the derivative of e to the y, it doesn't change. And then the second one is going to give us a minus e to the negative y. So now that I have that derivative, I'm going to go ahead and plug into our formula here. So the surface area is going to equal the integral from y is 0 to y equals the natural log of 2 of 2 pi times that curve x. So that's e to the y plus e to the negative y over 2. And while I'm here, we can go ahead and cancel out these 2's. And then inside the radical, we have 1 plus the derivative squared. I'm going to write the derivative as a fraction. So that's e to the y minus e to the negative y over 2, and that whole thing squared. Now we're going to clean up inside the square root here. And I'm going to go ahead and square the numerator. Obviously, 2 squared in the denominator is just 4. When we square the numerator, and I'm going to actually write it over here to the side, we end up with e to the 2y minus 2 e to the y, e to the negative y, plus e to the negative 2y. Now, note here in the middle, e to the y times e to the negative y, when we add our exponents, we end up with e to the 0 power, and e to the 0 power is just 1, so that middle term is really negative 2 times 1, or just negative 2. So again, squaring that numerator is going to give us e to the 2y minus 2 plus e to the negative 2y. So I'm going to go ahead and rewrite this, replacing that numerator with what I have here. So the first part of this isn't really going to change at all. Inside the fraction, I'm going to come back to the 1 here, but I'm going to rewrite this numerator as e to the 2y minus 2 plus e to the negative 2y. And that's going to be over a 4. I want to take that 1 and combine it with the fraction, so I'm going to write it as 4 over 4. So now I can go ahead and add those fractions inside the radical. Now when I add those fractions, I forgot to print the C. When I add those fractions, the 4 that came from that 1 and the negative 2, those are the only like terms. So when we combine them, we're going to have e to the 2y, now 4 minus 2 will create a plus 2 plus e to the negative 2y. So let me go ahead and write that out. We now have e to the 2y plus 2 plus e to the negative 2y all over 4. Well, this looks very familiar. we can factor e to the 2y plus 2 plus e to the negative 2y as e to the y plus e to the negative y quantity squared. So let me rewrite this one more time. So again, we have e to the y plus e to the negative y quantity squared over 4. Now we can take the square root here. The square root of e to the y plus e to the negative y squared is just going to be e to the y plus e to the negative y. Since I already have an e to the y plus e to the negative y, in total now I'm going to have e to the y plus e to the negative y squared. It's almost like a riddle here. And I'm not forgetting about that 4 in the denominator. Take the square root of 4, it's a 2, and I'm going to go ahead and just put pi over 2 up here in the front. So almost halfway there. At this point, I'm going to take that pi over 2 and I'm going to bring it in front of the integral, and then I'm going to multiply out the e to the y plus e to the negative y. So we have e to the 2y plus 2 plus e to the negative 2y dy. Now we are finally ready to integrate. Keep the pi over 2 here. E to the 2y is going to become 1/2 e to the 2y. That 2 is just going to be plus 2y when we integrate. E to the negative 2y is going to be a minus 1/2. And then it's e to the negative 2y. That's the same thing as 1 over e to the 2y. So I'm going to go ahead and write that as a fraction form. And we're going to look at this from 0 to the natural log of 2. So now it's a matter of just plugging in. I'm going to start with the natural log of 2. So we have 1/2, and then it's e to the 2 ln of 2 plus 2 ln of 2 minus 1 over 2e to the 2 ln of 2. Then minus, then we'll plug in the 0. E to the 2 times 0 is still e to the 0. E to the 0 power is 1, so we simply have a 1/2. 2 times 0 is 0, and then over here, we're going to have a negative 1/2. So that second set of parentheses is done. 1/2 minus 1/2 is 0. So now let me look here at the first set of parentheses and clean this up a little bit more. If you remember, 2 ln of 2 is the same thing as the ln of 2 squared, or the ln of 4. So I have e to the natural log of 4. The e and the natural log are going to cancel each other out, so we're simply left with 4. So I have 1/2 times 4, which is 2, plus 2 times the natural log of 2. Doing the same thing over here, I've got 1 over 2 times 4, so that'd be minus 1/8. Two minus 1/8, when you create a common denominator, you're going to get 15/8. So we have pi over 2 times 15/8 plus 2 times the natural log of 2. And I'll take that 2 in the denominator and distribute it. So we could rewrite this as pi times 15/16 plus the natural log of 2.